So this is a demonstration of the SaferSkin application for the skin sensitization potency prediction. The application is available over the internet through Safer World by Design platform, and it combines three predictive models, namely Bayesian network, multiple regression, and majority voting. Of these three, the most advanced is Bayesian network and also the most accurate one. Bayesian network takes as input physicochemical parameters, which are computed from the chemical structure that is provided by the user. So the user is supposed to provide the structure of the compound in the form of SMILE string or two-dimensional drawing. The second part of the input are experimental values from the three in vitro assays, the DPRA, keratinosens, and HCLAT. And we can have a look at one example. We have prepared a set of compounds with pre-filled values collected from the literature. So for example, for lactic acid, we can see that all these fields are already filled. And we can make a prediction. And here we get a quick overview with a comparison of three different models. And we see that all three models, Bayesian network, multiple regression, and majority voting, predict that compound is not a sensitizer in this case. And this is expected because all three in vitro assays are inactive in this case. And note that the Bayesian network provides also the prediction confidence, which is strong in this case. Strong confidence is because you have agreement between all three in vitro assays that the compound is inactive. And we can have a look in the detailed report. Here at the top, we see more detailed comparison of three predictive models. First, how they classify compound as sensitizer or non-sensitizer, then to which potency class it belongs, and then which PEC3 values is predicted. And note that majority voting is not designed to predict potency class or PEC3 value. Down we can see detailed report for the Bayesian network approach. And the result of Bayesian network is the probability distribution of PEC3 values. And we can see in this case, because all sources of evidence support that compound is not sensitizer, that distribution is concentrated in the low PEC3 value region. And also we report the percentile values from 50th to 90th percentile, and they're also designated on the graph. And in this case, they're all very close because the whole distribution is concentrated in a relatively small region. Further down, we can see repeated input parameters for the compound and also results of some intermediate calculations. And further down, we can also find similar reports for the other two predictive models. We can have a look at one more compound. For example, we can again select from the prepared set of compounds farnesyl. And again, the fields are already filled with the results from the literature. And we can see from the structure that compound is Michael acceptor. So we also turn this structural alert on. And if we make a prediction, now we get more interesting results. We see that Bayesian network and multiple regression predict that compound is weak or moderate sensitizer, and majority voting correctly predicts that compound is sensitizer. Note that Bayesian network has a now weak confidence in the prediction, and the reason is that we have disagreements between in vitro assays that are provided as input. Partly these inputs are supporting that compound is weak or moderate sensitizer. And we can see in the detailed report that probability distribution of PEC3 values now is much wider, and it spans 3 potency classes, and the highest probability is that the compound is weak sensitizer, but since there is conflicting evidence, we have only weak confidence into this prediction.